Hello everybody, I'm Shawnee Solon and I'm coming to you today with an FRQ from the 2013 AP Calculus AB test. On this problem, calculators are allowed, so let's dive in. A particle moves along a straight line. For the interval 0 to 5, the velocity of the particle is given by v of t equals -2 plus t squared plus 3t raised to the 6/5 power minus t cubed. And the position of the particle is given by s of t. It is known that s of 0 equals 10. Alright, so A. Final values of t in the interval 2 to 4, for which the speed of the particle is 2. So what's important to realize, first off, on this problem, is that it says speed, not velocity. Speed is only reliant on the magnitude, not on the direction. So really the problem is asking for you to find when the particle has a speed of 2 and -2. So I already started it down here. We're basically looking for the absolute value v of t has to equal 2. In order to do that, we need to use our calculator. And what I'm first going to do is plug in our original equation here, which is going to be -2 plus, pretend that x is a t, plus 3x, plus 3x raised to the 6/5 power minus t cubed. Again, pretend that x is a t. Alright, so I'm going to have that, and I'm going to have that line graphed. But in order to find when this particle equals 2, when the speed of this particle equals 2, I'm going to also graph 2, y equals 2, and y equals -2. And my reasoning for this is because I'm going to see where these two lines, y equals 2 and y equals -2, intersects with the original equation. And where they intersect is going to give me the time where the particle's speed reaches 2. So let's graph and see what we find here. Oh, that's looking nice. That's looking very nice. So what I'm going to do is second calc. Let's go down to intersect. Alrighty. Alright, so this is our first value. Also, the reason why I'm not going over here to see where it intersects is because the problem's asking me on the interval 2 to 4. And that's going to be later on. So, our first value that we have here is, let's take a look. Let's call that 3.118. Yeah, 3.128. And also we have to check for this next value because we have another one farther down. Whoops. Oh no. Let's try it again. Alright, our second value is going to be 3.473. Alright, so that is where the particle reaches the speed of 2. All I did was I found out where the graph intersected with the lines y equals 2 and y equals -2. Alright, so next we have B. Write an expression involving an integral that gives the position s of t, and use this expression to find the position of the particle at time t equals 5. Alright, this is kind of fun. Also, these problems are really going to be focused on the calculator. There's not much work to write here, besides the answers really. But for this one, we have to realize that the integral of v of t equals s of t. That's how it works. If you were to derive s of t, which is position, you would get velocity. If you were to derive velocity, you'd get acceleration. And also we have to realize that s of 0 equals 10. So that is our constant when we integrate v of t. We have that 10 added there. So what I'm going to do is go back to my calculator since I'm allowed to use it, and I'm going to integrate the function through this. All I did was I clicked math and I went down to number 9. Now it's asking me to find the particle at time t, so I'm going to set my bounds from 0 to 5. And I'm just going to plug in our equation that we have here that we've been working with. Okay, that's looking pretty good. Alrighty. We're just letting it calculate. And we get negative 19.2. But before we set that as our answer, we have to add that plus 10 there. That acts as our plus c of this problem. So we have to make sure to add it. So let me go back here. Let me just add the plus 10. And the actual answer is negative 9.2. So, yes, that is going to be s of 5 equals negative 9.2. All right, let's move on. Next is C. Find all times t in the interval 0 to 5 at which the particle changes direction. Justify your answer. Alrighty. So, first, let's look at the graph. Let's see where the particle changes direction. I should still have the graph. I'm just going to take out the y equals 2 and y equals negative 2. And let's just take a look at the graph here. Where the particle changes direction is where it crosses from the negative y-axis to the positive y-axis. So how I'm going to calculate where it changes direction is I'm going to find the zeros, because the zeros indicate where the line itself changes direction and where it becomes negative to positive or positive to negative. So what I'm going to do is second calc once again, and I'm going to go to 0, and I'm going to go all the way down here. I have to wrap tab for this one. Alrighty, and I'm going to go over here. Alright, we get x equals 0.536. Let's set that as one of our values here. T equals 0.536. That's where it changes from negative to positive. Next, we have to find later in the graph where it changes from positive to negative. Alrighty. All right, and we get 3.318. Let's round that up. All right, and those are our times for when the particle changes direction. All right, the last one, D. Is the speed of the particle increasing or decreasing at time t equals 4? Give a reason for your answer. All right, let's see. Let's go to our table here and see at t equals 4. Well, basically, first what you need to know is that if the speed of a particle and the acceleration both have the same sign, meaning if they both are negative or they both are positive, the particle will be increasing speed. But if they have conflicting signs, meaning if the speed is negative and the acceleration positive, the speed will decrease. It's not increasing. So we're looking to see if the signs of both the speed and the acceleration are the same. So to do that, I'm first going to look at my table here and see what t at time equals 4 gives me. And that is certainly a negative number, negative 11.48. Let's write that down really quick. So t of 4, or rather, let me write v of 4 is going to equal negative 11.48, and that is certainly less than 0. And next we have to find our acceleration. And what I'm going to do there is get back on my calculator, and I'm going to go to Math 8 to derive, and I'm going to plug in our equation here, and it will derive it for me. Alright, and then I want to set the x at 4, because that is what the problem is asking of me. It's wanting me to derive it at 4. And we get another negative number, negative 22.2957. So let's do this right here. A4 equals negative 22 point, let's say 296. So both of these numbers are negative, and guess what that means? That means the particle is increasing because the acceleration and the speed are both negative. Alright, so that is our FRQ problem. Thank you for listening, and I hope you guys learned something.